Okay, good morning. Today I'm going to go over modeling the Pythagorean theorem. So the Pythagorean theorem was something that was discovered in early civilization by a Greek mathematician with the last name Pythagoras. And what he discovered about right triangles we still use today. So what he discovered is if you take a right triangle like this and you draw a square off each side of the right triangle, so I'm going to draw a square off each side of the right triangle. What he noticed is if you take the area of the two smaller squares, so I'm going to take the area of this square right here, so this was a 3 by 3 square, so that has an area of 9. And then the other triangle, this is a 4 by 4 square, so 4 times 4 is 16, so the area is 16. You take the area of these two smaller triangles and add them together, so 9 plus 16 is 25. That's always going to be the area, I'm going to use a different color, of the largest square that's off the longest side right here. So if you notice, this is 1, 2, 3, 4, 5. So this is a 5 by 5 triangle, so this has an area of 25. So always, in any right triangle, he discovered that if you take the area of the two smaller triangles, you're always going to get the area of the larger triangle. So the area of this square A, we'll call this square A, and this square B is 9. The area of square B was 16. And then the area of square C, we'll call this square C, is 25. Now to find the side length, you can take the square root of the area, or you can just count the side length. So this is the side length of A would be 3 units. The side length of B is 4 units. And the side length of side C is 5 units. Notice that you can only add the areas, 9 plus 16 is 25, but you can't do that with the side length. So 3 plus 4 doesn't equal 5. But these would be the side lengths of this right triangle. This would have a side length of 3, 4, and then this is 5. So we can use the Pythagorean theorem to find the areas or side lengths in a right triangle. So let's look at this. So the area of A, they give us, this is going to be 64 square units. And we want to find the area of square B. We don't know that. They do give us the area of square C, which is 100. So since we know that the area of A plus the area of B equals C, and we know C is 100 and A is 64, how would we find the area of B? Well, if we subtract 100 minus 64, you get 36, so the area of square B would be 36. And you can check 64 plus 36 is 100. Now to find the side lengths of the area, well, if we know the area of this square is 64 square units, what number squared is 64? Well, if you take the square root of 64, you're going to get 8, because 8 times 8. This would be an 8 by 8 square. Side length B, what number times itself is 36? Is 6. And then, so we know this is 6. And then if the area of side of triangle, if the area of square C is 100, then we know that its side length is going to be 10, because 10 times 10 is 100. Or the square root of 100 is 10. Let's try another one. Okay, the area of this square is 144 square units. The area of square B is 25. That's given. These two are given. So if we add the two smaller squares, 144 plus 25 is 169. So we know that the area of square C is 169 units squared. We don't know what unit of measurement we're using, so I'm just going to use the word units. So area is always squared. So this is 144 units squared, 25 units squared, and then the area of the large square is 169 units squared. To find the side length, we're going to, what number times itself is 144, or you could take the square root of 144 and you're going to get 12. So that side of that square is just 12 units long, right here. Side length B would be 5 units because the square root of 25 is 5. And then the side length of square C, well, the square root of 169 is 13. So this side of this square is 13 units long. Okay, the last example, we're given the area of square A, which is 576. Again, this would be units squared. The area of square B is given, that's 49 units squared. So again, to find this area of square C, we can add these two areas together. 576, oops, cancel, clear. 576 plus 49 is 625. So the area of square C is 625 units squared. Now to find the side lengths, we can take the square roots of each of these. So the square root of 576, so you do second x squared, 576 is 24. So this is 24 units, that side of that triangle right here. So if I draw the triangle out here, this would be 24 units long. This side right here, side B, would be 7 units long because the square root of 49 is 7. And then the square root of 625, if you don't know that, you can come to your calculator. 625 square root is 25. So this last side of this triangle is 25 units. Oops. And that is how you model the Pythagorean theorem and find the areas of the squares and the side lengths of the 3 sides of the right triangle. So in summary, the 2 smaller areas, so when you have a right triangle, this square and this square, the sides that form the right angle, right here and here, these 2 areas, I'll call them A and B, are always going to add up to the area of square C, which is always going to be the largest square. This side right here is the longest side. And these 2 sides that form the right angle are the shorter sides. Okay, that's it.